Hello class, these are our notes for informal geometry. We are still in section 4.4. We're looking at the distance formula today. So in the XY Cartesian coordinate plane, so I'm just reading right up here at the top, plot the following 2 points, 2, 7, and 6, 1. So let's remember ordered pairs are x comma y. They are in alphabetical order. This is my x-axis, the horizontal, the vertical one's my y. So 2, 7, I would go over 2 for x and then up 7 for y. 6, 1, let's see, over 6 for x and up 1 for y. Draw the segment joining the 2 points. How could you find the distance between 2 points? Or between the 2 points? So what we're looking at doing here is we're looking at taking these 2 points on our graph, and if we actually make this into a triangle, then you can use the Pythagorean theorem. So we are going to make a right triangle and use the Pythagorean theorem. And the hypotenuse, our c value for the Pythagorean theorem, is going to allow us to find the distance between the 2 points. So in order to use the Pythagorean theorem, we need our length of both of our legs here. This is my right angle in the corner, so my legs are the green sides on this, not the hypotenuse that I'm looking for. So I can see on my x side, my x's go from 2 to 6. So how would I find the length of that side? How would I find the distance between those two? Well, I would have to subtract. 6 minus 2 would give me a length of 4 for this side. And I could similarly take my y values for the other leg, and 7 minus 1 would give me 6 for that one. So I have a triangle with legs that are 4 and 6. So if I think about a squared plus b squared equals c squared, a and b are my legs, those are 6 and 4. So 6 squared plus 4 squared equals c squared, and 6 squared is 36, 4 squared is 16, and then I do want to add them. That makes, let's see, 30, 40, 52. And then remember, we need to get rid of our square. So the inverse is taking a square root on both sides. Squares and roots, we could say, cancel each other out. And we're ignoring a negative answer here. It doesn't make sense for a triangle. So the square root of 52 is going to equal c, and we're going to use a calculator to approximate that to about 7.2. So I think the big question is we don't want to always graph and draw triangles if we're trying to find the distance between 2 points. So let's think about how we got this 4 here. We got it by looking at both of our x values, and we could have just counted the squares and said 4, but we figured out that distance by subtracting. So we took the 6 and the 2, we took our x values, and we subtracted. To figure out our height of the triangle, the y side, the b or a, whatever leg you want to call that there, what we had to do is we had to subtract our y values. We had a y value of 7, we had a y value of 1 to find the distance between. We would subtract again. So we had to subtract them, we had to square them. So that's where this distance formula is going to come from. So my distance formula, instead of c squared equals a squared plus b squared, so I'm kind of writing it backwards, it's a little bit weird. A is going to be that distance between my x's, so I'm going to write it as x sub 2 minus x sub 1 squared. I've got to show that I've got two different values of x and I'm subtracting. My c squared is going to be my distance squared. My b squared is going to be subtracting those y values. And then in order to find my distance, I would have to take a square root on both sides. So my distance is going to be the square root of the quantity x2 minus x1 squared plus y2 minus y1 squared. So that is my distance formula that I'm going to use. So it's a lot like the Pythagorean theorem, but a little bit trickier because we have some subtracting today. We're going to go ahead and try this on one problem, and then you'll have some time to practice it in class. So whenever I'm trying to memorize a new formula, I always want to start by writing it out. And then I want to think about my x values and my y values. So my x values are the first in each ordered pair, right? I have an x1, I have an x2, I have a y1, I have a y2. So ordered pairs are xy. My first point I'm labeling with 1s, the second one with 2s. And I want to subtract x2 minus x1, so 25 minus 14, because I'm trying to find the length of that side on the triangle. And then my y values would be negative 20 minus negative 15. And then again squaring it. So 25 minus 14, that's going to be 11 squared. Negative 20 minus a negative 15, well, minus negative means plus, so negative 20 plus 15 is a negative 5 squared. And we have to keep the parentheses until we square that. So this is going to be the square root of 121 plus 25. So I cannot just cancel squares and roots over this plus sign here. I have to keep going. And then I need to go ahead and add them. It's going to be the square root of 146. And then if I take that on a calculator, it gives me something like 12.083. It goes on and on and on. But if I want to round to the nearest tenth, then I look one more place after that. So I'm going to look at the 8, and because it's an 8, I'm going to round this place up, the 10th place up, and so I'm going to call it 12.1. So if you need help with your rounding today, please let me know. So big main ideas today are just, hey, we have a formula that we can find the distance between 2 points if we graph them. We could draw it out and we could use Pythagorean theorem, or we could go ahead and just use this distance formula and not have to do any graphing. So the distance formula and how to use it is really our main focus for the day. As always, if you have any questions, please make sure you ask.